Hello everybody, welcome to Yixuan's Lab 1 report demonstration. Hi, my name is Yixuan Li. This demonstration is about our advanced hardware design homework Laboratory 1, which is left-rotated and right-rotated simulation. Both of them are in 32 bits, and the software we're going to use is ISE Webpack, as well as the iSim simulation software. And the following is my demonstration. And when I already opened the ISE project navigator here, and we can see from here the implementation. Inside is my left rotated 32 bits .vhd file. Open it, and in .vhd file, there is all the code about how to implement the left shift rotator. Here, the difference from the lecture slides is I changed the input rotate amount from 5 to 6. Because from the laboratory requirement, we have to set the value bigger than 32. So I increased the rotate amount into 6 bits, which can get the value bigger than 32. Here is the architecture code. I just used the with select instructions to implement the left shift rotator, and it has 32 different ways. Okay, that's it. And let's go to see the simulation file. Open it. Under the simulation project, we added a test bench file. By using the test bench, we can get the simulation results to verify that if our .vhd file function is correct or not. Here is my test bench code. The port I set in the two inputs as A and B. The output is O. The input and output are both 32 bits, and the same, the rotate amount is 6 bits. And here I delete the clock because it's now that useful in our test bench this time. And here is the my simulus process. From the beginning, the process waits for 20 milliseconds, and then it can continue to process. Here's the start. I set the input as this value, and then I wrote a loop which can simulate B from 31 to 35. It have 5 different B values to test the input. Here has 5 test cases. And this instruction, which means that I convert the B value from 6 bits into from the integers into 6 bits. And then this is another, after 20 milliseconds, there's another A input, which I set a different value from the first one. And the same, I repeat the B value I chose 6 different B values. And this is the third one, This is the fourth one and the last eighth value. So those are my main process in my test bench code. Here, let's simulate my test bench to see if my function can meet my requirement. Let's do the behavioral check syntax to see that, okay, my test bench, it can work. Okay, let's simulate it. It took some time. Here it is. The name shows the 2 input and 1 output with their bit value. And here shows the here shows the specific value about each input and output value. Let's zoom the screen to find the best scale that we can read the data from the screen. Okay, here it is. We can see in the beginning of the 20 milliseconds, nothing happened. After 20 milliseconds, our code is running. When the input is 1100, 1100, when the rotate amount is 31, which means it's left shift rotate in 31 position. So we get the value is 011000110, which is correct. So let's go on to see the second one. When the rotate amount is 32, which means that nothing happens to the input. It should contain contain the value it is. So the output is the same value as the input. Here they are the same. We get the correct result. Let's go on to continue to verify the third one. Okay, let's go on. The B rotate amount value is 33, which means that let's 33 mode 32, the value is 1, which means it should left rotate 1 position. Left rotate 1 position, this one should go to in the tail. So the output is 1000, 11001, which is correct. Let's continue. When the B value into 35, in 35 mode 32, the value is 3, which means it should left rotate in into 3 position. So the first 3 bits should circular go to the tail, which we have the output that the 3 bits goes here, which is correct. So we can have a conclusion that our simulation result is correct. Okay, let's see the right rotate. The idea of the right shift rotator actually is the same with the left shift rotator. So we just only have to modify several code lines to meet its requirements. Here everything is the same. The only difference is the input value when different bit is chosen. Here's the .vhd file. Let's go to simulation, the right rotate test bench. Let's check the behavioral syntax. Okay, that's perfect. Let's open the simulation. Here, zoom it first. The same from the beginning. The 20 milliseconds, nothing happened. The code is not running. And after 20 milliseconds, it starts running. The first value of the A is, the input is 11000, 1100, which is the same value as the left shift rotator. And when B chose 31, let's see the output, which means it should be shift right into 31 position. Actually, it means by shift left to 1 position. So that makes us easier to check the output if it's correct. It left shift 1 position, which means this one should go to the end. It's 1000, 11001, which is correct. And the second one, when B is chosen 32, the output should be the same as the input. That's correct. When B changes value into 33, when 33 mode 32, the rest value is 1. That means it should right rotate 1 position. So the first bit value should, the last 0 should go to the first value here, because this number should go right for 1 position. So the output is 011000110, which can meet our requirement, and so on. When the B go to 34, it should right rotate into 2 position. So the 00 should go to the beginning. The output is 00110000, which is correct. And the last one, when B changes into 35, the 35 mode 32, the rest value is 3, which means the input should right rotate into 3 position. So 100 should go to the beginning. So it's 10011000001. Well, that's finished. So far, we can have the functional simulation to show that our code can meet our requirements. And that's it. Thanks for watching. That's my demonstration about Laboratory 1, the shift rotator. Thank you so much. This part is showing the timing simulation. Let's see the right rotated test bench, for example. Here, array input has the time delay.